Good morning and welcome back to Brodeur Land. We are still in week 5, but we are ready to move on to our final unit of the year, transformations. And today we're going to start transformations off with what we call translation. So let's take a look at today's learning intention. Today's learning intention says that students can translate a two-dimensional figure on a graph and understand that the original two-dimensional figure is congruent to the second translated figure. So let's dive in, let's jump in and talk about what in the world is translation, because none of you guys have heard about this yet, especially in 8th grade, because none of your math teachers have gotten to this unit. So let's take a look. Now, translation is really not that bad. We're going to take a look at a question where we got to translate this triangle right here. And then we're going to take a look at a second question right here where we have it already translated. We just got to write the rules. So let's take a look really quick. This one right here is actually the first question out of 4 that you have to complete for a grade. So we're going to do this one together so you have an idea of how to do it. Now, there are 2 ways you can approach this problem. I'm going to show you using coordinates first because that will show you the basics and kind of the fundamentals behind translation. But I will also show you a short way at the end. And a lot of you guys will probably like the short way, but I need to show you this way because that's important with what goes on with writing the rule later. So let's take a look. The first question says we need to translate this triangle right here, 1 unit to the left and 2 units up. Now, before we dive in, what we got to remember is what exactly are our X movements with translation and what are our Y movements. X movements are going to move right and left. Now, if you look at the X-axis, if you move to the right on the X-axis, your numbers get more positive. So that's going to have a positive association with it. That's important later. And then if you moved left on the x-axis, that's going to have a negative association. Same with y movement. If you move up on the y-axis, that would be a y movement, and it would be more of a positive movement. Now, if you went down on the y-axis, that would be down, but it would give you a negative association right there, and we're going to talk about that very shortly, but I wanted to get down movement. I think a lot of you guys might be thinking, well, Mr. Brodeur, that's pretty self-explanatory, but I don't want to assume. I want to make sure you guys all understand which movements go under which categories. Now, what we want to do first is we want to go to what we call our pre-image, which is our original image or the image we start with. Notice that's why I wrote pre-image, because that's what we call our original image on the graph. Now, what we're going to do is we're going to find the coordinates to these. So I'm going to go to y. Always start at your origin right there, so at 0, 0. And we're going to go over -1, -2, -3 for my x, but we don't go up or down any, so that's just going to be -3, 0. Now g, we're going to start at the origin, but we don't move left or right any, so that will be 0 for our x, but we'll go down -1, -2. And then m, we'll start back at the origin, but we'll go -1, -2, -3 for our x, and then -1, -2, -3, -4 for our y. So -3 and -4. So first I found all my coordinates for my pre-image or my original triangle. Now, this is where the positive and the negatives come into play. 1 unit to the left is a negative movement for our x movement. So when I do this, 1 movement to the left is going to affect our x points on our coordinates. And so I am not going to add 1, I am actually going to subtract 1 from all of my x coordinates right there. Now, my y movement says 2 units up, and up would give me more positive numbers. So I'm going to add 2 to all of my y values. And so that's why I really wanted to point out the differences between what's a negative movement, what's a positive movement, so that way you know whether you have to add or subtract. And then that will give us our new coordinate of where this image is, or sorry, this pre-image is translating. And notice right here, this is where we're going to put our new one. So our new y, -3 minus 1 gives us -4. 0 plus 2 gives me 2. Now some people might be thinking, why not a 2 or -2? Remember, same signs you add and keep. So that's why I got a -4 right there.
Mr. Brodeur, why are there apostrophes near the new points?
Oh, that's a good question. So I was going to get to that in a second, but we'll address that right now. Some of you guys might say, well, Mr. Brodeur, okay, you have your y, and that's a -3, 0. Now you have this y apostrophe, and you get -4, 2. This apostrophe is what we call prime. So I would actually call this y prime. And this helps us associate the difference between the two images. YGM that have no apostrophes are what we call our pre-image, our original image. When we go to plot these points in just a little bit, we're going to put apostrophes to say, here's our new image, or what we call our image. So that's a good question. And that's very important that you put these little apostrophes, or what we call primes, so we can know this is our second image and this is our pre-image. So let's finish this up. So 0 minus 1 is -1. -2 plus 2 is 0. -3 minus 1 is -4. -2 plus 2, -4 plus 2 gives us -2 right there. And then all we're going to do is plot these points. So we'll go back to our origin. We'll go -4, 1, 2, 3, 4, up 2. Now watch this. I put my point, but I don't want to forget which point is what. So when you plot your point, also write down your y prime. And notice I put my little prime right there. Now I'm going to go back to the origin, go to -1, 0. And that is my G, but not just G, G prime. And then go back to the origin, we'll go -1, 2, 3, 4, down 2. And that will give me M prime. Notice when I plotted my points, I right away put the letter and the prime, because I don't want to mix them up and go, wait, is that one my M? Is that one my Y? And that really helps me get things situated. And then we'll just connect all of our points to finish up our triangle. And you successfully translated. Now, there is a short way you could do this, and probably some of you guys were probably asking, well, Mr. Brodeur, can't I just go, let's say you went to G, and you started at your original G right there. And you said, well, I'm just literally going to go, Mr. Brodeur, 1 unit to the left and then 2 units up. I literally get to the same exact answer you just got right there. Is that okay? That is okay. And that would be the shorthand. So for example, if you started at Y, you could go 1 unit to the left and 2 units up. M, 1 unit to the left, 2 units up. So that is the short way. But like I said, the reason I showed you this way is this comes in handy in just a second when we go to write the translation rule for the problem below. So that's how you're going to do problem 1. Let's jump into the second problem where we have to write the translation rule. Now, I'm actually going to start off using the little shortcut rule at first, but we do have to do a particular notation when we do this. So first, let's just kind of figure out what in the world is going on. We have our pre-image and we have our image. Remember, pre-image is the original, your first image. This image with the primes is your new one. That's the second one. This one moved to that. So when you start, you want to first start with your original image, the ones without primes, and we're going to figure out what's going on here. So I'm just going to do A right here and figure out where it moves. So it looks like A moved 1, 2, 3, 4, 5, 6, 7, 8 units to the right. So I'm going to say 8 units to the right. And then I'm right here. So now I'm going to go 1, 2, 3, 4, 5, 6, 7. So we went 7 units to, sorry, I guess we could just say 7 units down. All right. So what I'm doing right here is just figuring out what is actually going on. What is my translation movements and things like that. Now, it kind of looks similar to here. And some people would say, Mr. Brodeur, can't I just say it translates 8 units to the right and 7 units down and be done? Well, that is part of it, but with translation, we actually want to make sure we actually use a particular notation. And here is the notation you want to use to get full credit on this problem. So what you want to do is you want to do x comma y, and that represents our original coordinates for A, C, and B. And what we're going to do is we're saying they translate, so I'm going to draw an arrow to my new coordinates. So x and y. Now notice I left a little bit of space right here because what we're going to do is say, what am I doing to this x that moves this a to a prime? Well, we just said it. We're moving 8 units to the right. Right is a positive movement, so we are going to add 8 to this x. And then right here for this y, we said we were moving 7 units down. Down was a negative movement, so I'm going to do minus 7 right there.
Mr. Brodeur, does this change the size or the shape of the figures?
So that's a good question. So if you notice, both in the previous and also this current problem, when you look at your images, they actually will stay the same. They will be congruent, which goes back to our learning intention. So on this one, the size of the shape did not change whatsoever. Same here. The size of the images are exactly the same. All we did was move their position. Kind of think about it like this. If you were rearranging your furniture in your room and all you did was just move your bed to the side or just move it to the left or to the right, that would just be a translation. You didn't make your bed larger or make your bed smaller. You just moved or translated its place. So in this case, they would be congruent. They'd be the same size. Now, just to finish this one off, this would be your final answer right here. And let me just recap on this one. X and Y represent our original points with our pre-image. And then all I did is just say, instead of in words, this is what it is in the notation. I'm taking my X coordinates and adding 8 to them, or pretty much moving to the right 8. I'm taking my Y coordinates and subtracting 7, going down 7 right there. And so yes, the words are nice, but we really want to see this notation for translation. So that is everything you need to know for translation. I hope this helps. You should have 3 more problems left to do. So let us know, let your teachers know if you have any questions. But until next time, Brodeur out. Peace.